What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're looking at lesson 6.1, perpendicular and angle bisectors. Our objectives are going to be able to use perpendicular bisectors to find measures, use those angle bisectors to find measures and distance relationships, and also write some equations for those. The first thing we're going to look at are the two leading vocabulary terms, and they're these. Perpendicular bisector is a line that is perpendicular to the segment at its midpoint. Remember, midpoint is going to be halfway through. And then equidistant is a point between the two figures that is the same distance from each figure. So just make sure you have those filled in before going on to the next slide. All right, so we have two theorems, and you've also received a theorem worksheet for this chapter, so I would be filling in and taking some notes on those as we go through them. The first one is theorem 6.1, and this is when you have to be given the perpendicular bisector in order to do this. And you know the segments are equal. Okay, perpendicular bisector theorem states this. In a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. For example, if CP is the perpendicular bisector of AB, then CA should be equal to CB. So that means these two blue lines right here should be equal. And the way we have to know that is we are given that perpendicular reasoning right here at that right angle, okay? The converse of that just states, in a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So this one, we start off by, we're given the segment, we know it's equal, then we know it's a perpendicular bisector. Okay, so like here, we know that the segments are equal. DA is equal to DB because of these two tick marks that we're seeing on DA and DB. Point D lies on the bisector plane of AB. So you can see if we continued letter C, if we go from C to D, that's going to end up being the bisector. Right now it doesn't show that because it's not going all the way through, but that's one way that we can prove it, okay? So what we're going to do here is we're going to find a few example measurements. Starting off here, we want to know what is RS. RS is here, and it looks like my perpendicular bisector has been shown. I have RQ is equal to QP, so that means 6.8 is also going to be RS. Onward, we've got EG and AD. AD ends up scooching over a little bit. AD should be here, but EG, let's start there. EG is this entire length, and again, this perpendicular bisector has already been named, so FG is also the same thing as FE, so EG would be from point E to point G, so that's 9.5 plus 9.5, and that's going to give us 19. AD is here. AD is equal to 3x plus 14, and I know that because of my indication of the perpendicular bisector. So what I would do is I would just set up an equation, 3x plus 14 is equal to 5x. I'm going to get my variables on the same side. So I have 14x is equal to 2x, dividing both sides by 2, x is equal to 7. The only thing is it doesn't just ask me to find whatever x is equal to, it tells me what is the distance of AD. So I'm going to go right here on AD and plug in my x. 5 times 7 does give me 35. So AD is equal to 35. Okay, let's flip over and talk about the second part of our notes. We have two more theorems. The angle bisector theorem states, if a point lies on the bisector of an angle, then it is equidistant from the two sides of the angle. For example, if AD is bisecting BAC and DB is perpendicular to AB and DC is perpendicular to AC. So again, we see our perpendicular notations right here. Then DB will be equal to DC. Okay, so this theorem basically states if you are given the bisector, you now know segments are equal. Okay, whereas the converse of that, we are going to be given the segments equal. We can then say we know the bisector. Let's read this theorem. If a point is in the interior of an angle and is equidistant from the two sides of the angle, then it lies on the bisector of the angle. So here we go. DB is perpendicular to AB. We know that. DC is perpendicular to AC. We also know that according to my two right angles here. Okay? And it also shows me that DB is equal to DC. So that means AD, this is my ray, is bisecting my entire angle of BAC. Okay, so this is just angle bisector theorem. If I know the bisector, then I can state my segments are equal. And then the converse of the angle bisector theorem, I'm given my equal segments, so then I can know where my bisector is. We're going to try this question next, and it says, use the diagram and the given information to find the indicated measure. Each problem is separate from one another. So 4, 5, and 6 are all separate. Number 4, let's start with that. BD bisects ABC, and DC is equal to 6.9. So I'm just going to write some information here. So if DC is 6.9, then DA also should be 6.9, because if I'm bisecting, that means this matches with this. Okay, let's clear out and talk about number 5. Number 5 states BD bisects ABC, and AD is equal to 3z plus 7, and CD is equal to 2z plus 11. Find CD. So what we do know is that because BD is bisecting ABC, I can say that CD is equal to AD. So what I would do is I would just plug in those two expressions. CD is 2z plus 11, and AD is 3z plus 7. I'm going to move all of my variables to the right and move my numbers to the left. So I get z is equal to 4. Since I know z is equal to 4, I just plug it in right back into my original question. 2 times 4 is 8, and 8 plus 11 is 19. So CD is equal to 19. The last one, it says, find the measure of ABC, so this entire angle, when AD is equal to 3.2, CD is equal to 3.2, and the measure DBC is equal to 39. Well, because of this, I'm able to know that if ABC is showing me that's a large angle and DA matches DC, then BD is the bisector. So that means 39 is exactly half of that full angle. So all I can do here is take 39 and multiply it by 2 to get 78 degrees for the entire measurement angle of ABC. All right, last little bit. Write an equation of the perpendicular bisector of the segment with endpoints -2, 3, and Q is 4, 1. The first thing we're going to need to do is find the midpoint of both of these, find the midpoint of this segment. So remember, midpoint is take your x's, which be careful because it's cut off. X's are -2 and 4, divide them by 2. And my y's are 3 and 1, divide those by 2. -2 plus 4 is 2, 2 divided by 2 is 1, 3 plus 1 is 4, 4 divided by 2 is 2. So my midpoint is 1, 2. Now, I also need to find the slope of this, okay? So what would be helpful is to find my slope. Remember, slope can be found by change in y over change in x. So after I find this, then I can start getting my equation. For slope, change in y could be 1 minus 3 over change in x, 4 minus -2. 1 minus 3 is -2, and 4 minus -2, that's 4 plus 2 are 6. And then that ends up getting me to 1/3 as my slope. So now what I'm going to do is I'm going to plug my midpoint into my slope and use point slope form. Okay, which looks like this. Y minus y1, which is from my midpoint, so y minus 2 is equal to 3 as my slope that is perpendicular. That's something, so this would be my slope. Perpendicular slope is just reversed and opposite, okay? And then parentheses x minus my 1 from my midpoint. Let's go ahead and combine by distributing 3x minus 3, and then add my 2 to the other side. I get y is equal to 3x minus 1. Okay, so step 1, find the midpoint of your points, of your segment. Step 2, find the slope of that segment. And then step 3, use that perpendicular slope, and plug it into point slope form. Okay, the next one I'm going to have you try on your own. So let's go ahead and pause the video here. Again, this cut off a little bit. So we have 3, -1, and -1, -5. Just make sure you pay close attention to those. I'm going to pause the video here so you can try it. And when you're ready, go ahead and get started. All right, step 1, let's find that midpoint. So midpoint is I'm taking my x's, 3 plus -1, dividing that by 2, and -1 plus -5, also dividing that by 2. 3 plus -1 is 2, 2 divided by 2 is 1. And then -1 plus -5 is -6. -6 divided by 2 is going to give me -3. So here is my midpoint. Then I need to find my slope. So slope can be found by the change in y over the change in x. So I'm going to do my y's. -1 minus -5 over 3 minus -1. This is going to be 4 over 4, which is 1. So my perpendicular slope would just be -1. Okay. Then my last point, or my last step, is to take point slope form, use midpoint and the perpendicular slope. Y minus -3 is equal to, we have m now is our -1, and then x minus x1, which is x minus 1. Let's go ahead and clean up y minus -3 would be y plus 3, and then distribute my -1 to get -1x plus 1. Subtract 3 from both sides. I'm going to get y is equal to -x minus 2. Okay. That is going to conclude our notes for today on lesson 6.1. Thanks for tuning in. Make sure you filled in your theorem sheet as we continue to work through this.